All right, so as a review, we have these two classes. We have class 1 that has the instance variables 1 underscore 1 and 1 underscore 2, method 1 and method 2. And we have a second class, class 2, which has the instance variables 2 1, 2 2, and the methods method 3 and method 4. So let's come over here to the code and we create two objects, C1 and C2. But we created them kind of strangely. Let's see. Actually, let's go ahead and change this up right here. So this is pretty straightforward, right? What we're doing on the first, object is we're creating a class 1 object, right? Because both sides have class 1 on them. So on the right side of the equal sign, we're creating a class 1 object, and we are storing it into a variable that can contain class 1 objects. So no problems here, right? If I go ahead and run this, let's back up a bit. And then on the second line, we're creating a class 2 object, and we're putting it into a variable that can store class 2 objects. So great, nothing confusing here, pretty straightforward. So let's go through a couple prints and see which ones would error out and which ones wouldn't. We have the first print, which is a C1. This is this class right here. And we're trying to print the instance variable 1 underscore 1. That should be fine, right? Because this is an instance variable of the class 1, and C1 is a variable of type class 1. An object of type class 1 that is stored in a variable of type class 1. All right, perfect. Everything's great. Now here we're saying C1, we're trying to print out 2 underscore 2. Well, C1 is a class 1 object, so I'm coming over here, I'm looking in my instance variables, 2 underscore 2 is not there. So this second print is trying to print an instance variable of class 2. But class 1 has no relationship with class 2, right? If we look right here at this line of code. So this print would error out. So this one's check, that's great. Now we're looking at this third print. C2 is a C2 class 2 object, and we're trying to print 2 underscore 2. And it's right there, so boom, no problems there. And so we put a check mark. And then the next one I'm saying C2, which is a class 2 object, I'm trying to print 1 underscore 2, which is a class 1 instance variable. So this guy would error out. Right. So let's put a cross there. Okay. So basically the rule is objects can only print out instance variables that are defined in the class that they represent, right? Pretty straightforward. And here in C1 is the class 1 object, and we're trying to run method 2. That is fine because it's right there, no error. Class 1 is trying to run method 3. It is not found here, not found there. It is found here, right? And again, C1 has no relationship to class 2. So that is going to error us out. Class 2 is trying to run method 2. C2 is a class 2 object, and method 2 is not found here. So that is going to error out. C2 dot method 3, C2 is a class 2 object, and the method 3 is right there, so this one is going to be fine. Okay, so this is really straightforward, and when things get a little bit more interesting is when you do things like this. You take a class 2 object on the right side of the equal sign, and you save it into a variable that can contain class 1 objects. So what this is doing here is it is typecasting the class 2 object as type class 1 to stuff it into this variable. Okay. So what happens when you typecast an object from one type to another, to a superclass? You strip it of all its unique instance variables. So this C2 variable does not have any of these instance variables, and it doesn't have any of these methods either, because we stuffed it into a class 1, a variable that can store class 1 objects. So we typecast it. It's like stuffing a triangle into a mold that's type square, right? You cut off all the arms of the triangle of the star when you do that, right? And you're just left with the square. So you're losing all the unique instance variables and methods of class 2. Okay. But things get kind of interesting because if I have a method down here that is overriding a method from class 1, then if I do this, right? So I have method 2 defined in class 2, right? And method 2 is also defined here in class 1. Right? So what happens in this situation? Well, let's see, where is it? It's right here, right? What happens here? Well, C2 is type class 1. And so when you run method 2, hey, it's here. It's one of the methods in class 1, so it's available to run. This line of code is going to run without any error, right? But the weird thing is that it first looks for the definition in the class, the type of object that the object originally was before it was typecasted, right? So it will run the method here first. Okay, so it runs the definition in class 2. That's the weird thing about what happens with this guy. So the way that I like to think about it, and it's kind of simple, is this class on the left side define which which methods are available to run. Let me make it smaller. Trying to move it somewhere. Okay. Which methods are available to run is the class that is on the left side of the equal sign. And then on the right side of the equal sign, it's where the method is defined. So in this situation, if C2 runs a method, it has to be defined in class 1. But if that method is overridden and also defined in class 2, then that's the method that's going to run. That's the definition that's going to run. So that idea right there comes up a whole lot in these classes and objects types of questions. I would say it's 20% of the questions regarding classes and objects has to deal with that concept. So if you're good with that, it's going to be the key to unlocking quite a few of those questions.